I was watching the gameplay reveal of EA's upcoming Immortals of Avium, which is one of the first AAA games being released in Unreal Engine 5.1, and I was positively impressed with how the team behind the game has managed to bring a lot of the cool features that we've been seeing in Unreal Engine demos to a AAA title that has to run on lower-end hardware. That has been one of the main concerns from the PC enthusiast community. Next-gen graphics demos look cool and all, but how do they translate into actual games that have to run on a wide range of hardware? We can see that UE5's impressive tech is used extensively, with few concessions made to make the game scalable to lower-end systems inspired by Immortals. And as I've been doing in recent months, I've decided to take a look at what developers and artists are working on as far as next-gen graphics are concerned, as well as look at what companies like Nvidia are exploring that could hint at what the next generation of hardware will be capable of achieving. Today's video is sponsored by Urcdkeys.com. If you buy a retail Windows 10 key, you could spend $100 or more. But if you buy an OEM key from Urcdkeys.com, a Windows 10 Pro key will cost you only $15 when you use the coupon code C25. The keys work globally, and you can even get a free upgrade from Microsoft to Windows 11 if you wish. After you've made your purchase, you will find your key in your purchased orders in the Urcdkeys website. Click on Get Keys and copy the key. Then in Windows, click on Start and type Activate, and then on Activation Settings. Then click Change Product Key, pasting the key you just purchased, and click Next. That's it. Your copy of Windows is now activated. If you want Office 2021 Professional, you can use the same C25 discount code and get it for just $60. Urcdkeys is also having a spring sale with some cool, affordable mechanical keyboards, gaming mice, and even chairs. A big thanks to Urcdkeys.com for sponsoring today's video. Check the links in the video description to get your cheap OEM Windows keys today. Before we take a look at some incredible graphics for upcoming games, let's take a quick look at the tech behind Immortals of Avium. Nanite is one of the key technologies used in Immortals. Nanite, which I've covered several times before, is a micro-polygon geometry system which intelligently adjusts the level of detail of any in-game object depending on how close you are to it. So if you have an object that's far away enough that you can make out fine details on it even if they were there, Nanite will actually make the object physically less complex on the fly so that the game doesn't waste resources rendering it fully. We can see that in action in the environments demo for the game. This is also evident in the in-game cutscenes, where the level of detail of the backgrounds is adjusted when the game goes from a close-up shot to a distant one, with some blur and other effects added where it makes sense for this type of scene. But this also allows for a really seamless transition from cutscene to gameplay, with varying levels of detail in the distant objects. Very impressive stuff. The character models look incredible, especially with UE5's Lumen technology casting realistic lighting and reflections, with light bouncing and picking up the colors and allowing that to be seen in nearby static and dynamic objects. All these minor details compound into a more immersive experience. Thanks to Unreal Engine's world partition, the game also features some enormous levels, with the devs claiming some of the levels are the equivalent of 25 to 30 kilometers in length, despite this not being an open-world game. Now, looking at the minimum and recommended specs for the game, we see that you'll need an 8GB GPU to play at 1080p 60 FPS, with EA recommending at least an RTX 2080 or a 5700 XT. Interestingly, on the CPU side, EA recommends as a minimum an 8-core CPU. For a while now, I've stopped recommending 6-core CPUs because I've found the user experience when using Windows, consuming content and doing work to be not ideal compared to a decent 8-core CPU. Maybe I've just been spoiled, but in my opinion, unless you're on a budget, I would avoid 6-core CPUs. For gaming, 6 cores have been fine though, especially if you're only playing the game and not doing anything else. But judging by the minimum specs for this upcoming UE5 game, it could be the case that 8 cores will become a requirement, even for games, going forward. I doubt that 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 is indeed the case. I don't think a ton of extensive testing goes into finding the actual minimum specs for these games, and I would be very surprised if something like a 13400F or a 5600X or a 7600X has trouble running this game. But it is a new engine with some very large environments and novel gameplay mechanics that involve a lot of objects and particle effects on screen all at the same time. So who knows? It's definitely something to keep an eye out for, and I'll be testing how well the game scales from 6 to 16 cores when it comes out. Could 6 cores be on the way out when it comes to gaming? I tweeted about this and my followers' reactions were, as expected, very passionate. Most people seem convinced that a 6 core will be absolutely fine for this game. Share your opinion down in the comments. For 1440p 60, the recommended GPU is at least a 3080 Ti or a 6800 XT, so I'm assuming that to run this at 4K with max settings natively, you'll probably need a 4090. The game will be coming out on the 20th of July, so roughly 3 months from now. One of the hidden benefits of Unreal Engine 5's scalability is for porting games to future hardware releases, particularly next-gen consoles. EA can easily recompile the game to take advantage of more powerful hardware and add higher resolution assets and enable new UE5 features with minimal development work required. So UE5 doesn't just scale down to lower-end hardware, it can also make it easy to scale up as new hardware comes out. We'll look at some incredible UE5 demos in a second, running on mid-range hardware, by the way. Another thing to look out for will be gameplay elements or environments that just were not possible before on the scale that UE5 allows. It will be interesting to see how UE5 moves gaming forward beyond just better graphics. Speaking of hardware, Nvidia recently released a video on real-time path tracing, which I think we should take a quick look at. So there are already at least 4 commercially released games that support real-time path tracing. There's Quake 2 RTX, Minecraft RTX, Portal RTX, and the recently released Overdrive mode for Cyberpunk 2077. What do these games all have in common? They are all Nvidia sponsored. Real-time path tracing is appealing for both developers, as it can reduce development work when it comes to production lighting, but also for the end user, as you can get ultra-realistic and accurate lighting in games, making them more immersive, if you have the hardware grunt to run it at decent frame rates. Now you might be wondering, what is the difference between ray tracing and path tracing? So ray tracing traces a single ray of light into the scene from the start to the end location. Path tracing uses ray tracing to trace various path segments. So if we reverse a path segment, like in this example, we see a ray traced from our viewpoint, so that's the camera, to the tree, and then inside the tree to another branch, and then into the cloud, then into the sun where it originates. So that's one path segment, reversed, where we used ray tracing to trace each ray from a start to an endpoint. Path tracing allows for realistic global illumination and reflections and shadows to be cast, resulting in a hyper-realistic shot. This requires immense hardware processing, so it's been delegated to offline rendering of one frame at a time, particularly for movies. But now we're getting to the point where we can do path tracing in real time with monstrous GPUs like the RTX 4090, along with technological advancements in resolution scaling like the LSS and FSR. AI will also contribute to reducing the processing power required massively going forward. Of course, techniques that one could call cheating are also used extensively to reduce the processing needed, like low samples plus denoising, or a technique called radiance caching. Check my last video on this topic if you want to see some exclusive footage of an upcoming path tracing engine. All of this would indicate that in the next generation of hardware from Nvidia, we will see new ways to more efficiently use shaders, so that calls are only done when necessary. We're already seeing these cheating techniques, so to speak, in Ada, like the opacity micromaps that classify parts of objects, so that opacity states are encoded on micro triangles. The RT cores understand this format, so the ray tracing overhead can be greatly reduced. You can think of it as Nvidia creating systems that analyze and classify the scene in detailed ways, so that the RT cores can then later come along and only ray trace the strictly necessary parts, and do so more accurately because of all this additional classification that is being done prior to the rendering stage. So don't be surprised if the next generation of Nvidia GPUs don't actually see an exponential increase in RT cores, but rather get additional systems to reduce the RT core overhead. I did a video several years ago on how Amdahl's law law dictates that even if you were to add more RT cores to the GPU, if there's a bottleneck somewhere else, there will be no gains in ray tracing performance. NVIDIA's plan seems to be reducing the bottlenecks elsewhere before adding more processing grunt to the real-time ray tracing. At least that's the idea I get from the way that GPUs have evolved from the 20 series to the 40 series now. AMD are doing some work in this area as well, including a Brixelizer that creates sparse distance fields in games. So basically it will be their open source solution to reducing ray tracing overhead when traversing a scene. This hasn't been released yet, but if it's something you're interested in, let me know in the comments or on Twitter, and I might cover it in more detail when it comes out. Now moving on to some of the incredible graphics demos and projects for upcoming games that have emerged since I last covered this topic. We start with an update on a favorite of mine, the incredible looking Unrecord from game dev Drama. If you remember from the last time I covered this game, it's a first-person shooter that you play from the perspective of a tactical police officer's body cam. This Unreal Engine game is a narrative-driven FPS inspired by classic crime and thriller stories. The detail on the environments looks absolutely incredible, as well as the animations, but the global illumination really takes the immersiveness to a whole new level. The novel perspective certainly adds to the immersion and the tension, but I worry that those sensitive to motion sickness, like myself, might not be able to enjoy the game. I always turn off head bobbing and camera shake in games, and in some cases I just have to skip games altogether because of how physically sick they make me feel, and it seems to be getting worse with age. So I hope the devs take this into account and offer a more traditional first-person perspective as an option, preferably with an FOV slider. Nevertheless, this is definitely one of the most interesting first-person games on the horizon, and the level of realism in the graphics is pretty stunning. Next, let's take a look at some of the work done by an artist that I've covered before, Pasquale Chionti from game studio Torn Banner, who make the Chivalry series. Pasquale made this scene using Unreal Engine 5, and what's interesting about it, beyond it looking fantastic, is that we get to see both a path tracing version and a Lumen version of the same scene. There's barely any difference in terms of image quality, but the Lumen version will run better and require less hardware resources to present a similar image. So while Nvidia seems keen on pushing path tracing and fixed function hardware to run it, Epic and their Unreal Engine seem to have some software-based alternatives that will extend the life of existing GPUs much longer than Nvidia would like. From the same artist comes this Dark Souls-inspired scene, which showcases volumetric ground fog with dust particles using Unreal Engine's Niagara technology. I really like the way the light from the moon cuts through the fog on the ground, and the light from the torches bouncing on the surfaces creates a very realistic and immersive environment. One of my favorite games of the last few years was The Witcher 3, and the Blood and Wine DLC in particular was a great addition to the main game, with much lighter environments well suited to Geralt's twilight years. Technical vegetation artist Michael Gerard from Ubisoft recently published a recreation of the Toussaint region from the game in Unreal Engine 5. While not a game per se, it gives us an idea of what the already announced Witcher Polaris could look like. Note that CD Projekt Red has already confirmed that both the next Witcher game and the Witcher 1 remake will be using Unreal Engine 5 and not the in-house Red engine. One of the things I find interesting here is that Michael was able to tailor the engine to the more saturated fantasy look of the Witcher games. Not all Unreal Engine 5 games have to be about that hyper-realistic look. A similar exercise comes from Leo Torres, who recreated the Skyrim town of Whiterun in Unreal Engine 5.2. This is a law visualization that more accurately represents how large Skyrim's towns should actually be if the hardware limitations of 10 years ago hadn't limited Bethesda to making the Skyrim towns much smaller than they are in the game's lore. Gameplay is obviously also important to consider. You don't really want a big empty town with not much to do, you know, like in the most recent Ubisoft open world games. This demo is running on a 3060 Ti at a rather cinematic 30 FPS. With graphics tweaks and resolution scaling, it seems reasonable to think that even a mid-range last-gen card should be able to run the most demanding UE5 games that will be coming out in the next year. From the same artist comes the rather impressive-looking Meridian, a sci-fi demo made in Unreal Engine 5.1. If you notice an upgrade in shadow quality here, it's because this is using an experimental RTX lighting system for directional and skylights. So this was all made before the recent UE5 updates, and NVIDIA's new path tracing API became publicly available. One can imagine how much more realistic scenes like this will be in the coming months as artists experiment with the new tools, and as GPU makers like AMD and NVIDIA release new APIs that better integrate with Epic's engine. One technology in particular that seems crucial to me is AMD's GPU Open FSR3, which the company teased a couple of weeks ago at GDC. Unlike NVIDIA's walled garden, FSR3 is part of an open source SDK and will run on AMD, NVIDIA, and Intel GPUs. For everyone out there to be able to enjoy this level of detail in upcoming games, FSR3 will be crucial in democratizing access to next-gen graphics, especially considering how expensive high-end GPUs have become and how NVIDIA has chosen the forced obsolescence route by not supporting DLSS 3 on their older GPUs. Going back to actual announced games, one upcoming game that caught my eye is Ayla, which, you've guessed it, is being made with Unreal Engine 5. This comes from Brazilian studio Pulsatrix Studios. In this game, you are a beta tester for horror games that are created by an artificial intelligence in the year 2035. This AI, called Ayla, creates games based on human fears. In the game, the AI uses machine learning to create the scariest possible experiences for the main character. Eventually, the AI evolves and starts meddling in the real world. It's an interesting premise that could create some very immersive gameplay experiences. The level design looks very detailed, and the realistic lighting capabilities of UE5 seem to be used to great effect for some moody, scary environments. Games that take place in crammed, small areas generally have a lot more hardware resources available to them, so I could see the horror genre really taking advantage of UE5's technologies to create some very disturbingly detailed environments and gore. By the way, if you're looking for a career change, making 3D assets that are Nanite and Lumen compatible to sell on asset stores seems like something that could generate a decent income. Just a thought. Before we wrap this one up, let's take a look at a demo that combines all of the latest technologies together into an absolutely stunning, hyper-realistic scenario. One interesting development in the latest versions of UE5 is the ability to use ray tracing along with Nanite-enabled meshes, which didn't work particularly well before with translucent objects. In this scene from Leo Torres, we see the new Nanite ray tracing mode, so global illumination and reflections are handled by Lumen, but the translucency and shadows are done with RTX. The author notes that in the scenes where the camera is outside the terrarium, the Lumen global illumination doesn't quite work yet, so some tricks were used to compensate for that. I love these sorts of demos that push the boundaries of what's possible on today's hardware, and note that this is running on a 3060 Ti. The cumulative impact of Nanite, Lumen, and RTX, when everything works together, along with upscaling technologies, will make these sorts of graphics possible in actual games much sooner than people realize. There are new incredible demos and gameplay popping up every day, and being a graphics ho myself, I love covering these. Make sure you're subscribed to the channel so you don't miss my future coverage of hardware and graphics advancements. This video was made possible by my awesome patrons. By supporting my channel on Patreon, you will gain access to the Cortex Discord server, where you can talk to me directly and join a welcoming community of tech enthusiasts. If you can't contribute at this time, then give this video a like and share it, as that really helps. Thanks for watching, and until the next one.